All right, folks, I'm here, and welcome to the Daily Space Weather. We see another sunspot has formed. Very high latitude here. Well up off the equator there. Another Cycle 25 sunspot in effect. And should be called Sunspot 2756. Later today, and there you can see former Sunspot 2755. And this active region over here is not a sunspot, it's just a plage. So we see some Cycle 25 activity and some Cycle 24 activity happening at the same time. Here's the view in 304 angstroms, and we're looking at 9 hours of solar activity here today on January 9th. Exciting stuff going on, folks. Exciting stuff. And we're going to zoom in on that sunspot in a moment. A whole bunch of umbra have popped up. It's got some power. There are the magnetic fields. And again, Cycle 25 activity coupled with Cycle 24 activity all at the same time. There's a Cycle 24 plage, Cycle 25 plage, and a Cycle 25 sunspot. So welcome to Cycle 25 and indeed the Neo-Renaissance. Here's a view of the umbrae from that sunspot, and they are significant. It's going to be beta class when it gets named. So a little bit of X-ray uptick there also. And we have been hit by the coronal mass ejection as forecasted, folks. So let's get into some more data here. Here's the view of the sunspot in 171 angstroms at HelioViewer. And we're going to fade out to the magnetic fields here. And there you can see the fields associated with that sunspot group. Several umbrae there. So we're going to go back to a day with a sunspot today, folks. Looks like 2020 is not starting out with lots and lots of sunspot-free days. Sorry for all you grand solar minimum folks out there. Don't freak out. You want to have a sunspot cycle. And let's look at some more stuff here, like the GOES X-ray imager. And you're going to see that sunspot there in the upper right pop out with authority. There you see it just comes to life. And for that viewer who was commenting about how sunspots never form while they're facing the Earth, well, right there you have one. As sunspots do form when they're facing the Earth regularly. Let's look at the GOES X-ray flux. And we see the background for the GOES 15 long is in B class, actually. So a little uptick there in X-ray flux. The GOES 16 short, still at very low levels. So, but anyway, a small uptick in solar activity. And for that, we thank you. Sunspot situation has kicked up, and that's a good thing. 10.7 centimeter radial flux is currently at 74 solar flux units. And we've just gotten into geomagnetic unrest, folks. That just kicked up while we did show prep here, as the effects of the coronal mass ejection are felt. I don't know why no other channels called it. We're going to show you more information about it in a minute, but first, let's look at cosmic rays. And we see a small uptick over the past 30 days at Apatity. There's the Apatity neutron monitor, as well as at the Barentsburg neutron monitor. Not a big uptick, more of a small uptick. And there's the last 30 days at Barentsburg also. Next we'll look at Athens, Greece. And there's the data at the Athens neutron monitor. A little more flat on the past 30 days. Next we'll look at Mexico City as we traverse the world looking at cosmic ray monitors. And there's the situation in Mexico City, fairly flat there the past 30 days. Next we'll look at Moscow. And not sending data yet this decade. And lastly, we'll look at Oulu, Finland, as well as DOMC Antarctica. DOMB Antarctica not sending data. So there's Oulu. Here's the lack of data at DOMB, even though it's summer down there. And there's the data from DOMC. Nothing to write home about there. If you want to monitor cosmic rays yourself, we always leave links to the Network of Cosmic Ray Stations site in the description. And here's the signature of that coronal mass ejection. We see just the density kicking up here, all at the same time, getting the KP index into a 4. So the speed didn't really come up there. It looked like it was kicking up last night, but it really didn't do so. And there you can see the phi angle shifting around at the same time as the solar plasma hits as forecasted. Now, if you weren't aware, we were talking about this 3 days ago. So we actually called this coronal mass ejection before it even fully released from the corona. And here's a clip if you haven't watched it. From that view, as you can see it in the LASCO C3. So there's the LASCO C3 view. And you can see the date stamps there. Anyway, there's the view from stereo A. 1800 UT. And we caught that as it happened. And it was a long duration coronal mass ejection. So we wouldn't be surprised to see a long duration coronal mass ejection hitting the Earth. So we expect the KP to be elevated for the next, I'll say 12 hours, as it took about 24 hours for that coronal mass ejection to fully release from the sun. Almost exactly 24 hours, in fact. And there's the data from ACE, and you can see that solar wind density coming up suddenly there from below 1 proton per cubic centimeter. We also did see the real-time solar wind graph expand here, as we saw a reading all the way up over 1,100 kilometers per second. You can see the graph was expanded to 1,200 there. Perhaps an anomalous reading there. Most likely is, as we don't see anything like that. Oh, the ACE data was expanded too, so it looks like there was a small little pulse of ultra-high power there. High velocity, that is. And the electron flux is quite flatlined here. Very cratered, very low levels of electron flux. And we are expecting this to pop back up in the next 48 hours. When that coronal mass ejection ends, 24 hours or so from there, we will see an increase in the electron flux, as well as GPS errors around the equator, especially at noon. Let's look at the ionosphere. Here's 6 hours of data, courtesy Australian Government Bureau of Meteorology. As we've been seeing ionospheric anomalies in the South Pacific, where it charges up at nighttime for the last at least 6 weeks, more like 2 months. And we see it continuing here, not as extreme as it has been in the past. So a little bit of a relaxation. Let's just bring up the last image here and move on, as we've got a ton of things to cover yet. And there's the latest image, that one coming in at 9 o'clock UT. That's universal time for you new viewers. And there's the onset of that coronal mass ejection, and you can see it did cause some data loss there from the GOES 16, it looks like. Now these things get into what we call the CCD bakeout mode, where the charge couple device shuts down in order to prevent damage. So anyway, there's the GOES magnetometer data, and we are in the process of crossing the current sheet at the same time that a coronal mass ejection hits. We could already be in the North Pole-oriented portion of the current sheet. In fact, my guess would be that we already are. This data 1 hour and 41 minutes old from the Gong 2. And let's just bring up the last image there. And you can see North Pole-oriented portion of the current sheet is probably already upon you. Please leave a comment if you're viewing from a place besides Earth. For you new viewers out there, this is stereo A, and this is stereo B, and this Gong 2 data is derived from about 51 magnetometers on Earth, as well as at stereo A and B. It gives us insight into what's going on with solar activity that we would not otherwise have. And talk about forecastability. The Gong 2 has provided me with information that with the ability to forecast things that I would have never expected to have. Here's the Geospace Magnetosphere movie, and we're just looking at the pressure as that coronal mass ejection is currently hitting, and there you can see a big pulse coming in around 8 o'clock UT. Lots of pressure there, magnetohydrodynamic pressure, especially in the magnetotail. So that's something to keep an eye on throughout the day. In fact, I'm going to let that play a second time. And when I say ion, the pun is intentional. Next, we're going to look at the ground geospace magnetic perturbations, geospace delta B. And when we say delta in science, folks, we mean change. And we see significant induced current. As the magnetosphere was very weak and that coronal mass ejection just kind of hit when the shields were down, so to speak, we see major current induced over the Canadian North Pole, as well as over the South Pole, which is clearly creeping into the southern Indian Ocean. And we see less perturbations over the Siberian North Pole here, as has been the case. Let's look at the polar view here. We don't always look at this view, but we're going to look at it today, as we expect to see spiral-like formations at the poles, and indeed we do, as a giant Birkeland current connects to the Earth. And here you should see a big spike come in. There's that big spike at 8 o'clock. And it looks like pure magnetism, folks. And let's move on to more data. And we had a quake, we had a large quake come in just as we did show prep. A 6.3 just struck Russia as we did show prep. So there you go, 6.3 right there. Let's check the location of that one before we go down to the bottom of the list. This one coming in at 8:38 UT. Looks like it's in the middle of nowhere. Let's check the interactive map. Looks like a very isolated location there. And there's a location of that located north of the Bering Sea. Just coming in as we did show prep, folks. Is it pure luck? Is it divine providence? Is it a combination of the two, or is it none of the above? So we did see some deep earthquakes kick off for the past 24 hours. Let's just scroll up the list. And there's a deep one already located at Indonesia at a 4.5 magnitude. And I would love to be able to scroll. There we go. Yes, it's a win. There's a deep quake at the Philippines, as well as a deep quake at Dominica. Not a welcome thing to see more deep quakes in the Caribbean, as Puerto Rico has taken some damage. There's that 5.1 at Dominica, 144 kilometers depth. And I'm just going to scroll up the list here, folks. Bear with me as I'm getting this information at the same time as you are. Here's a deep quake south of the Fiji Islands. That one's at 183 kilometers depth. A very deep quake at Fiji, 620 kilometers, 4.6 magnitude. If that happened at the surface, that would be about a 6.6. There's another deep quake there in the southern Atlantic Ocean, near the South Sandwich Islands, 4.4 magnitude, 221 kilometers depth. I just want to check this one in Hawaii real quick. There's one near Pahala. It's just a small one, 2.8 magnitude. And another deep quake near Sagave, Wallis, and Futuna, 418 kilometers depth, 4.4 magnitude. And again, there's that 6.3 coming in right as we did the show prep. Let's talk about Viking runes and climate change. Now, this is a new story you're going to see in the Science Wires today about Viking runes. And let's talk about Vikings and climate change. Now, the Vikings are known as one of the first real estate brokers, as when it got warm in the medieval period, the Vikings tried to sell real estate in Greenland, a place not really fit for habitability, but it got so warm that farming started kicking up. in Greenland, and so the Vikings started trying to sell land. They stayed at Iceland, where it's much more temperate due to its proximity to the Gulf Stream. And what were the Vikings scared of? Cold. Because cold is what kills people. As the Earth, for the past several million years, has been much colder overall than it is now. Researchers suggest the runestone could be speaking of a different kind of battle, the conflict between light and darkness, warmth and cold, life and death. They had to take into account a number of events in the author of the text Lifeline, which could have seemed extremely ominous. A powerful solar storm colored the sky in dramatic shades of red, crop yields suffered from an extremely cold summer, and later a solar eclipse occurred just after sunrise. So, interesting stuff from the Vikings, who again were afraid of the cold, not of the warm. As if the planet got 1 or 2 degrees warmer than it is now, it would increase crop yields. And you wouldn't burn up, folks, believe it or not. Here's where the pressure maps are located, courtesy of windy.com, who, by the way, has a great mobile app. And we're just going to let that advance via the GFS forecast model. So we'll let that advance about 24 hours from when we made the video. It's currently 4:19. And let's let that advance. And there's where we expect pressure to be according to the GFS model at 12 Zulu time, 12 Universal time, otherwise known as 12 Greenwich Mean Time, noon tomorrow. There's where stuff will be according to that model. And let's look at the volcanoes. Mount Abico back on the list, which is producing a 10,000-foot ash plume up there near Kamchatka. Next, Mount Aso, unknown volcanic cloud there. Sakurajima, not surprisingly, back on the list there, as we see an increase in seismicity around the area. Sakurajima producing an 8,000-foot ash plume. Krakatau, the deadliest volcano on Earth, at least over the past couple of years, has produced a 4,000-foot ash plume. Tokono, exploding. Flight level 6,000. Sangay, flight level 19,000 as it explodes also. Revenador exploding, 16,000-foot plume there. Sabancaya exploding, producing a 24,000-foot ash plume. Please do not attempt to pole vault Sabancaya. Here's the lightning maps. That's where lightning's striking on the globe right now, if you were wondering. And here is the jet stream of the eastern world. We do see some extreme meridional jet stream flow there north of the Middle East, as well as a more coherent jet stream over places like northern India. Let's look at the western world's jet streams. And there's the west. Again, we've got jet stream flowing in the wrong direction there, east to west over the central Atlantic, where the jet stream is still making two 180-degree bends. So we've got doubled up, tripled up jet streams and all kinds of weird stuff going on, folks. Here is the U.S. Doppler radar map for your value-added services. Not a lot to comment on there. Here's a U.S. water vapor map. And we're going to zoom in once again on western Texas, as there's a convergence going on over there. Let's just zoom in on that region real quick for all of you weather pornographers who are interested in things like Hall currents. Because you see all those parallel lines, folks? They ain't chemtrails. They ain't contrails. They're not caused by CO2. Were you aware that all your weather comes from space? Perhaps that's why you watch the channel. Who knows? In any case, Major pressure gradients kicking off there. And let's get on to some more stuff. But first, let's talk about Patron. Thanks, patrons. Please consider becoming a patron if you haven't done so yet, as we are expanding our operation in various different ways. Some of which we'll tell you about, some of which we won't tell you about, because it'll be a surprise. So check it out. Fund us that way, if you like. We've also got other links to help support our cause below the video. And please take a moment to press like and subscribe on YouTube if you haven't done so. And we are also on various other social media, so click the description below the video and check out our links. And thanks, Smash Team. And welcome, everybody, to the That Is Censored and That Is a Sinkhole, where we hope our viewers can understand the distinction between their ass, pictured here on the left, and a hole in the ground, pictured here on the right. Let's talk about Paul Krugman, a Keynesian economist who does not know the difference between his ass and a hole in the ground. Apparently, he's been looking at some holes that he shouldn't be looking at, or allegedly, his IP address was hacked by child pornographers, which sounds like a bunch of BS to me. Paul Krugman, a guy who thinks inflation and debt and fiat money and banking cartels are just fantastic, and that the economy is just peachy. New York Times columnist Paul Krugman tweeted on Wednesday that someone is using his IP address, a numerical label assigned to each device on the internet, to download child pornography. He suggested that while he may be a random target, it could be an attempt to QAnon me. Anyway, he's deleted the tweet because it's such a bizarre thing. But here's what the tweet said. Well, I'm on my phone with my computer security service, and as I understand it, someone compromised my IP address and is using it to download child pornography. I might just be a random target, but it could be an attempt to QAnon me. It's an ugly world out there, an ugly world full of debt and inflation, thanks to economic retardation. Economic fools, such as Paul Krugman, as Keynesian economics are failing all around the world. So thanks, Paul, and enjoy trying to get ahead of your little story about child porn. And welcome to the cosmology segment, folks. Now, taking 2 steps forward and 1 step back, talking about dark matter. And so we got 2 articles here that we put in the description. And we're talking about all kinds of things like gravitational lensing. And no, I don't believe that gravity causes the lensing. I believe that magnetic fields cause the lensing. And here's a bunch of images that are allegedly gravitationally lensed. But the article is about cold dark matter. Yes. Oh my gosh. They've discovered very small clumps of cold dark matter while they look at a quasar, which means they're looking right down a relativistic jet and wondering why the quasar looks lensed. And anyway, read the article. Take it with a grain of salt. In fact, take it with a truckload. Next, we're going to look at this article on Universe Today, which is much better, calling into question the ridiculous idea of dark matter, which is basically just concocted to explain why galaxies are moving in unknown ways. Some folks out there are claiming the universe is made up of as much as 95% dark matter and dark energy, and it's going to be a great day for astronomy, cosmology, and indeed physics when the whole idea of dark matter and dark energy goes down the drain. This all goes back to when Edwin Hubble calculated the relation between a galaxy's distance and its redshift. We're not going to read the article for you. This one is suggesting that dark energy makes up 68% of the matter energy in the universe. And it's there's the article. I don't know what else to tell you except redshift is misunderstood when looking at distant objects. Cepheid variables are part of the reason why I didn't get an astronomy degree, because I didn't want to calculate Cepheid variables for a decade. So yeah, read the article. This is the 2 steps forward after the 1 step back regarding dark matter and dark energy, as this is basically debunking it. And I'm not sure where I was going with this. Let me see if I can read a quote for you. It's a teaser. The new study casts doubt on our assumption about type 1a supernovae. Over 9 years, the team made detailed spectrographic observations of all the nearby galaxies where supernova occurred. From this, they calculated the ages of the galaxies. They also looked at the light curves of the supernovae that occurred in the galaxies. Since the galaxies are all within the range of Cepheid variables, they knew the distance without making assumptions about the supernova. Then they looked at the light curve of a supernova, depended on the overall age of stars in the host galaxy, and none of this really supports the concordance dark matter theory of the cosmos. Just watch as the Big Bang and all of this nonsense breaks down. And I don't know, I think it's going to have to be rewritten from scratch. What say you? Here's where stuff's located in the solar system. Here's where stuff will be in a week, as Venus is finally making its way onto our side of the sun, and all of the other planets are piled up on the other side. Here's where stuff is above my head. It's 4:29. Do you know where your constellations are? If you've got a low horizon, perhaps check out Mars as it rises, right as the moon sets. Should make for some good viewing if you've got a telescope. Leave a comment. We'll feature it. Let's talk about GRS 716-249, massive radio source believed to be a black hole by all too many astronomers. Now, I don't believe in black holes. I don't know if you're aware. I call them massive radio sources, as I have since the mid-90s. Back then, I wondered why they called them massive radio sources. But now I understand that black holes are math in search of observations. Anyway, there was a very interesting set of transients that kicked off in 2016 at GRS 716-249. This black hole is located about 7,800 light years away. It is believed to be a low-mass X-ray binary, so not so similar to Cygnus X3. However, some major transients happened. It was studied in great detail, so read all about that. The New Star Observatory had something to do with it. Shout out to the New Star Observatory. Read the article. This one is from phys.org. If you want to follow the transients of 1716-249, there they are, and you can see that crazy wild spike there right at the beginning of 2016. And it actually began in December of 2015 and then suddenly popped back down to a quiescent state. If you want to study the transients of all your favorite objects, head to the Neil Gorell Swift-Bat X-ray Observatory. And every object you look for won't be there, but just to give you an example of how to look for stuff, hit Control F, type Sagittarius A star, SGR space A, and there's the core of the Milky Way galaxy, which looks like it's missing some data here from the end of 2019. And since Cygnus X1 is also referenced in that article, let's just look at Cygnus X1 just for the fun of it. And there are the transients from Cygnus X1. Now, Cygnus X1 is a famous object in that it is the first widely believed object to be a black hole. It was famously bet on by Carl Sagan and Stephen Hawking back in the 1980s or possibly even the 1970s. And this is the first object believed to be a black hole. Lots and lots of radio sources are monitored there, including Cygnus A and Cygnus X3 and all kinds of other interesting stuff. If you're not familiar with Cygnus A, well, our channel is going to make you familiar with Cygnus A. Here it is invisible, and it looks like an N in there. Look at how distorted that area looks. It's all boxy and weird looking. Well, here's what it looks like with the radio and X-ray included. And you can see the relativistic jets coming out here and then expanding. probably creating star-forming regions out here at the end of the jets, where the matter is able to condense into stars. Because stars are made of condensed matter, folks. We're going to be making a shirt about Cygnus A, the 3C405 shirt. That's the other name for Cygnus A, by the way, 3C405. The second brightest radio source in the entire sky, second only to the sun. Kind of weird with an object being over 500 million light years distance, able to get more power in terms of its radio emissions to Earth than even the core of our own galaxy. So anyway, welcome to the Neo-Renaissance, folks. If you haven't checked out smAsho yet, please do. Check it out. Scroll down. Click the link for the newly unveiled smAsho forum. Go to the forum. We just put up a new topic today, and the topic is the most. If you'd like to contribute to the most, check it out. It's about creating a list of the most objects in the cosmos. We're looking for the most luminous, highest energy, strongest radio signals, the most massive, the largest, etc. So I started by doing 2, and here they are. Strongest radio source as measured from Earth, the Sun. Strongest radio source from beyond the solar system, massive radio galaxy 3C405, aka Cygnus A. So set yourself a login, contribute. And again, please don't forget to press like and subscribe on YouTube if you haven't yet done so. And if you're not watching on Twitch, twitch.tv/smAsho, you're not viewing the videos live at this point. This one was indeed streamed live to Twitch. Thanks again, patrons. Again, please consider becoming a patron if you haven't done so, as we've got a lot of stuff to do in our mission for the year. And thanks again, Smash team. Stay tuned for a bonus of each. We're going to look at 94 angstroms view here of the local dwarf, and that's 48 hours of activity. We'll see sunspot 2756 form right at the end of the video here. And you can see there's a calibration move that happens there with the SDO, where it tries to make sure the solar disk is directly in the middle. It's not because of an alien spacecraft tractor beam, folks. Anyway, we are out. Thanks for tuning in. Remember to stare at the sun, and when you do so, don't drink. And if you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back, and that atherosclerosis absent from your veins.